parameters and constants. So what I want you to do, I want you to just pause for a minute, and you can see that I'll be sharing a lot of code with you later on in the course, and I'm just gonna ask you to read it. Chances are you'll be able to understand it better than me explaining it sentence by sentence and whatnot. So what I want you to do is I want you to do the following. You have written a couple of codes. One is a module here and another module here, and I just want you to know what does this do. Okay, this is what happened. Take a pause and figure out what's it doing. Okay, hopefully you had the time to actually take the pause and actually figure out what it does. So in this slides, what I want to do is I want to explain what a parameter is and what a constant is and the differences between them. Parameters actually are very useful in creating something scalable. So you probably have figured out what this is. It's actually just it just sums 4 bits and just sums add bits. This is just an adder, basically, okay, a parameterized adder. And this parameterized adder does not know how many bits, kind of like what I showed you in here. Okay, so in here I showed you a bunch of full adders. Okay, so this one here is 4, but this here, the parameter makes it more generic. So how generic it is? Well, it's n generic. Okay, so parameters usually comes the module. You give the module name, you put a hashtag, and then you say parameter and n equals 4. And you can have more than one parameter. So in this particular case, it's actually the number of bits. So I created basically a binary adder that is parameterized. So instead of specifying exactly 4, what I'm specifying is n. Okay, and I'm just doing, well, the input is n, like -1, basically 4 bits input. The output has to be 4 bits, and I have a C out, which is the carry out. So a local parameter, on the other hand, is actually local. It does not get exposed outside, okay? So what you have in here is local power, which is a parameter, okay? So the difference between local power is a constant, okay? The difference between a parameter and a constant is the parameter is exposed to the outside world, the constant is not. So I have n1 in my code in here. I cannot change it, I cannot see it, I cannot do anything if I'm actually using this particular module somewhere else. Okay, it's just internal to the module, and that's what we call a constant, even though it's called a local parameter. A local parameter is just a constant. So a parameter is just more generic, and you can see what the code is doing. Okay, read it, it's actually really interesting, and hopefully you guys get to understand why I'm doing this here and adding the 0. Okay, so it's this is the concatenation operator. I'm just basically putting whatever is in B, I'm concatenating 0 to its most significant bit. I'm doing the same in here. Basically, I'm doing, instead of having, and this here is 4, instead of 4-bit summation, I'm doing a 5-bit summation. So I will have the most significant bit will be my carry. Okay, and then I basically extract it out. Anyway, take a look at it. It's actually really neat how I wrote it. What I want you to see in here is the following. So in this particular case, I have a couple of things. I have some 4-bit numbers and I have some 8-bit numbers, and I'm basically adding A4 and B4, which is 4-bit, and I'm adding A8 and B8, and that's basically 8 bits, okay? And of course, I have the carry for the 4 bits and the carry for the 8-bit. What I did in here is I did the same. I instantiated a couple of these modules, or a couple of this module. I just instantiated a couple of instances here and here. One is called unit 1, the other one is called unit 2. Both, one is a 4-bit adder, the other one is an 8-bit adder. It's really neat. The parameter allowed me to go and just specify it. And it's the same thing as you can use it in order or named port, similar to the input and output. It's like when you instantiate. So the parameters are in, like, the way you actually specify what parameter you want is the same. In this particular case, in this code, you can see that the parameter took its default value 4. So this, whenever you say equal 4, that means if you don't specify it, just consider it 4. So you created the 4-bit adder. Parameters are really useful, and you're gonna see it in the next lab. That was just a very, very quick primer for System Verilog. I just wanted to remind you of all the basic structures that you can actually utilize. And we have used it only in combinational circuits. Later on, we're going to be using these particular structures exactly. They're the same exact, but the usage changes a little bit in sequential circuits.